For decades, scientists have advanced the evolutionary theory of origins. Of an Earth that formed by slow cooling of molten mass over 4.5 billion years to make the foundation rocks of the continents, the granites. Of life that began spontaneously in some primeval sea and then evolved over hundreds of millions of years to produce the many life forms we see on the Earth today. Of the eons-long formation and drying up of these primeval seas to produce sedimentary rocks such as in the Grand Canyon, with the canyon itself carved by the Colorado River over millions of years. Of coal and oil deposits, buried in sedimentary rocks around the world, which presumably required millions upon millions of years to form from the accumulation and decomposition of vegetation existing in ages past. But have scientists considered all the evidence in arriving at their theory of an anciently evolving Earth? What if there was evidence in the granites themselves that showed they formed rapidly instead of by slow cooling? What if there was evidence that these sedimentary formations composing the Grand Canyon were deposited quickly instead of slowly? What if there was evidence the canyon itself was carved over a short time by rapid erosional processes? What if there was evidence revealing that coal and oil can form rapidly and did so recently? What if there was evidence that dinosaurs existed not millions of years ago, but just a few thousand years ago? And what if it was found that natural laws, the glue which holds the evolutionary framework together, cannot explain everything in Earth history? We would then be forced to consider another model of Earth history, one that would acknowledge the possibility that geological rates of change in the past were much greater than those observed today. In this scenario, it would take much less time for various geological events to occur. We would then have all the ingredients for concluding that the Earth is actually quite young. But is there any published scientific evidence which challenges the evolutionary view of an ancient Earth and supports a young Earth? Scientist Dr. Robert Gentry, while working at the Oak Ridge National Laboratory in Tennessee, has found just that, publishing evidence which challenges the long time period of Earth's history. In 1977, the Research Communications Network published a special breakthrough report on the results of Dr. Gentry's scientific publications, characterizing their implications as follows. Current physical laws may not have governed the past. Earth's primordial crustal rocks, rather than cooling and solidifying over millions of years, crystallized almost instantaneously. Some geological formations thought to be 100 million years old are in reality only several thousand years old. Grant these propositions and any researcher will tell you the entire structure of the historical natural sciences would dissolve into formlessness. Few certainties would remain. Yet these very possibilities, and others equally challenging, have been suggested in a remarkable series of papers published over the past several years in the world's foremost scientific journals, Nature, Science, and Annual Review of Nuclear Science, among others. From Research Communications Network, Breakthrough Report 1977. Part of Dr. Gentry's work referred to in this quote pertained to his work with coalified wood from what is known as the Colorado Plateau, a broad geographical region encompassing parts of Colorado, Utah, Arizona, and New Mexico. Using the microscope and more advanced laboratory equipment, he analyzed these specimens of coalified wood for various types of radioactivity. His results help us to understand how long it takes coal to form, the age of the coal, and the age of the Earth itself.
What averse vast energy resources. Before we can answer the question as to the age of coal and the time of its formation, we need to ask the question, where did coal come from? Here in this coal mine in Price, Utah, we have the answer. Here is a log, almost completely turned to coal. There are thousands of such logs in this mine and in other mines here in the Price area. This fact tells us that given the right conditions of pressure and temperature and water and time, that wood and other vegetation will turn to coal. The question is, how long did it take for that to happen?
Robert Gentry and his son David, an associate in his father's work, explore this topic together.
To answer this question, we need to look at coalified wood specimens from uranium mines instead of coalified wood, like this log, from one of the coal mines here in the Price, Utah area. This coalified wood specimen comes from La Salle, Utah, a uranium mine. Its presumed geologic age is around 140 million years.
This specimen of coalified wood comes from a uranium mine in the Temple Mountain area here in Utah. Its presumed age is also 140 million years. But look how closely this specimen resembles this other piece of wood. They're nearly identical. It's interesting to note that this other piece of wood was derived from a fresh piece of wood like this, just a few weeks ago.
This close similarity raises an important question. Is it really true that this piece of coalified wood from La Salle, Utah, and this piece of coalified wood from Temple Mountain, Utah, are really 140 million years older than this piece of wood which David and I recently obtained in some of our experiments? Not really. Locked in these and other coalified wood specimens from uranium mines is some remarkable evidence that tells quite a different story. To see that evidence requires that the coalified wood specimens be mounted in epoxy, thinly sliced, and then placed on glass slides for observation under the microscope. Under the microscope can be seen discolorations produced by radioactive particles ejected from tiny centers. Some are circular, others are elliptical, as can be seen in these photographs. These circular and elliptical halos required a special sequence of events to form, so special, in fact, that they completely overthrow the idea of an ancient age of coal, pointing instead to coal's recent formation, geologically speaking. To explain the halos requires that at one time, water-saturated logs were buried in what are now considered to be several different geologic formations: the Eocene, Jurassic, and Triassic. Later, uranium solutions infiltrated those water-saturated logs, and uranium decay products, radioactivity, was collected at tiny sites in each of those logs. That radioactivity decayed over the next several months to a half year, ejecting particles and producing spherical radiation-damaged regions, halos around those tiny sites. In cross-section, they appear to be circular. They were formed by the decay of secondary polonium, derived from the decay of uranium. Then there was a compression event. Something applied pressure to the top of all these formations. The logs were compressed, and when the logs were compressed, the halos were compressed. This brings us to an important point. We know that these logs had not turned to coal at the time the compression occurred. Here's a piece of coal. Coal doesn't compress. It shatters, as we can easily see. All the information we've seen thus far would indicate that these events were simultaneous in all these geologic formations. But there is even more evidence of that. When uranium invaded the wood, it left some of its decay product since the time that it invaded the wood. I've measured both the amount of uranium in these coalified logs and also the amount of lead, the decay product. On the assumption that the decay of uranium to lead has been uniform, it's an assumption we'll discuss later, we arrive at the conclusion that all these logs were buried together quite recently. How recently? In 1976, I published my results of the studies on these logs in the October 15, 1976 issue of Science. Here's what I said in this report. Such extraordinary values, referring to these lead-uranium ratios, admit the possibility that both the initial uranium infiltration and coalification could possibly have occurred within the past several thousand years. In other words, I was suggesting that coal could form very rapidly, geologically speaking. It contradicted the conventional way in which people have thought about the formation of coal. What was the reaction of the scientific community to this new data? I received a letter from Professor Raphael Kazman of Louisiana State University several months later, January 27, 1977. Dear Dr. Gentry, I have been patiently scanning the letters section of Science since the publication by you and your colleagues of your findings on radio halos. The silence is deafening. I think it can be interpreted as stunned silence. Your results will not greatly trouble the engineer, but the impact on the science of geology in possibly changing the accepted views as to the duration of geologic time will be felt for many years. Very truly yours, Raphael Kazman. Soon thereafter, Professor Kazman organized a symposium. It was entitled, It's About Time, 4.5 billion years. Is the Earth really 4.5 billion years old? When the results of the symposium were written up and published in the September 1978 issue of Geo-Times, here's what was said. However, since the deposits from which the coalified wood was obtained are considered to be at least of Cretaceous age and possibly of Jurassic or Triassic age, the ratio between uranium-238 and lead-206 should be low. Instead, some such halos have been found with uranium-lead ratios ranging from about 2,200 to over 64,000. If isotope ratios are to be used as a basis for geologic dating, then presently accepted ages may be too high by a factor of 10,000, admitting the possibility that the ages of the formation are to be measured in millennia. Translated, that means several thousand years for the formation of coal and all of those geologic formations. This information has remained unchallenged and unrefuted in the open scientific literature since it was published in 1976. We are therefore entitled to draw some rather firm conclusions about the data. Geologists have assumed the Eocene was about 60 million years ago, the Cretaceous about 110 million years ago, the Jurassic 160 million years ago, and the Triassic 225 million years ago. But the results that we presented contradict that information. It's showing instead the simultaneous burial of all these formations about several thousand years ago. These results pertain to the origin and age of coal wherever it is found.
Catherine Hill Bay, Australia. Not far from this coastal area near Flat Rocks Point is an object of extreme geological interest, an ancient tree. The fossilized remains of this tree can be seen extending through over 12 feet of sedimentary layers between two coal seams located here. Years ago, when a mining company excavated the layers exposing the tree, the bottom of the tree could be seen extending down to the lower coal seam. Since that time, the lower part of the tree has broken off. Even now, in its reduced length, The tree extends through layers geologists normally theorize to have taken hundreds of thousands of years to accumulate. But these layers could not have taken long ages to accumulate because the tree would have rotted long before the sediments would have had time to accumulate around it. Rather, this tree is mute testimony to its catastrophic burial by at least 2 sequences of volcanic ash deposits. As the evidence indicates, the tree was probably buried in a series of closely spaced volcanic ash flows, perhaps similar to the catastrophic burial of thousands of trees at Mount St. Helens in Washington state.
But if coal did form rapidly, we expect to find places where geologists have encountered extreme difficulties in explaining its origin by slow accumulation of vegetation. So let's take a closer look at the evidence for coal formation as it occurs in the spectacular Powder River Basin in Wyoming and Montana.
The Amax Eagle Butte open pit mine near Gillette, Wyoming, exposes the vast coal reserves made visible by the strip mining methods used here. The Eagle Butte mine boasts of coal layers or seams with thicknesses ranging up to 120 feet. Eagle Butte mine is part of a much larger coal-rich area known as the Powder River Basin. This gigantic 10,000 square mile reserve, situated between the Black Hills of South Dakota on the east and the Bighorn Mountains on the west, extends northward to the Yellowstone River in Montana and southward to Casper, Wyoming. The immensity of the Powder River Basin coal deposits has attracted the attention of geologists for decades. Such interest was documented in the May 1993 issue of Earth magazine. The article, Powder River Coal, Geologic Enigma, Environmental Dilemma, included these statements. Powder River's coal seams run remarkably thick and unsullied by other material. Usually, unwanted sediment such as clay washes over a deposit before coal seams can get very thick. But Powder River coal is packed in immense strips, some more than 200 feet thick. These seams stretch vast distances up and down the basin. They're hundreds of miles long. They're 50 miles wide, says James McClurg, a geologist at the University of Wyoming. They're not little pods of an acre or two. They're immense things. McClurg, who studied the basin for more than a decade, says no other place in the world has as many seams 50 feet or more thick. But the Powder River Basin is not only an economic resource. To geologists, it's also an intriguing scientific enigma. Geologists have been studying the basin for more than a century, largely to answer a baffling question. How did the seams get so massive? Or more precisely, why weren't the seams diluted by influxes of clay and other impurities before they thickened? As McClurg puts it, how on earth did things remain constant enough so that you can get 200 feet of coal? The genesis of any kind of coal demands a precise sequence of events, however. If you don't get all of them, you don't get coal, explains McClurg. And to get seams more than 200 feet thick, low in impurities and low in sulfur, is a remarkable achievement. He adds, it would be like blindfolding yourself, spinning around and hitting the center of a dartboard 100 times in a row.
But if coal did not form slowly, is there any laboratory evidence showing that it can form rapidly?
In this demonstration, Robert and David Gentry begin to answer this question.
Earlier we took a piece of wood like this, inserted it in this steel pipe, added some water, and then sealed it up. The next step is to put it in the oven at about 160 degrees centigrade for 2 weeks. Now we're ready to examine the results of this experiment.
As we can see, this wood is now darker in color. It's also softer. A chemical reaction between the steam and the wood under pressure has caused these changes to occur. This specimen isn't coal yet, but clearly the process of coalification has begun.
The question is, would coal result if this experiment, or a variation of it, continued for a longer period of time?
Scientists at Argonne National Laboratory have answered this question in a series of experiments performed in the 1980s. One of the earliest reports about their work appeared in the magazine Chemical and Engineering News in the November 21, 1983 issue. On page 42 of this issue, we read the following quote: "Chemists at Argonne National Laboratory have succeeded in making a type of artificial coal from naturally occurring materials. The process is much less severe than formerly thought to be necessary and provides some new insights into coal structure and how to alter it." Later, after their published reports appeared in the science journal Organic Geochemistry, the British science journal Nature reported on the success of their experiments. On page 316 of the journal Nature, March 28, 1985, we read the following: "Winans and his colleagues at Argonne National Laboratory have taken less than 1 year to prepare a thoroughly characterized synthetic coal. The material they produce is indistinguishable from the real thing by all the techniques so far applied to it, and its synthesis raises many interesting questions in coal chemistry." To understand their results, let's first note the basic structure of wood. Two major wood components are cellulose and lignin. The lignin basically acts as a binding agent for the cellulose fibers. Several variations of the argon experiment were run, but the successful formula combined lignin and clay with heat, about 150 degrees Celsius, in the absence of oxygen. Over a period of about 8 months, artificial coal was produced. The rapidity with which coal can form when steam interacts with wood under pressure leads us to ask, can steam or hot water also produce the rapid transformation of organic matter to oil? An article, Water, Water Everywhere, published in the February 20, 1993 issue of Science News, answers this question. Researchers at Exxon discovered water acted an essential part in the formation of oil. Efforts to synthesize oil met with failure until very hot water was added to the reactor vessel containing the source rock sample. When this was done, a layer of oil was found on top of the water at the end of the experiment. This result proves there is an alternate path to the production of oil in the earth, with superheated water playing a major role. The article indicated this discovery could wreak havoc with established ideas about oil formation. Actually, however, other natural events are already wreaking havoc with conventional theories. Incredibly enough, certain researchers, one at Oregon State University, have published reports showing evidence of present-day oil formation in the Guaymas Basin in the Gulf of California. Right now, in the Gulf of California, below 6,000 feet of water, is an accumulation of organic sediments derived from marine algae and other organic sources. Below this, superheated water is being pushed up by a deep heat source through these sediments. Oil is being formed in the interaction of organic sediments with superheated water. This hydrothermal oil from the Guaymas Basin is virtually indistinguishable from crude oils obtained from wells drilled in the earth. The implications of this discovery can hardly be overestimated. The possibility must be entertained that the genesis of the reservoir crude oils abundant throughout the world may be explained by hydrothermal processes similar to what's happening in the Guaymas Basin. But instead of an open dispersion of oil directly into the seawater, a closed system could easily be visualized where a reservoir of crude could be collected. It is conceivable that a worldwide flood was instrumental in the production of the tremendous oil reserves of the Middle East and elsewhere. The vast amounts of vegetation buried by such a flood, mixed with superheated water similar to that detected in the Guaymas Basin, could produce oil in the volumes we see today. Depending on the burial conditions, the organic matter would be transformed to either oil or coal. Is there a model of Earth history incorporating these features? One which allows the formation of the world's large oil and coal reserves over a much shorter time than has been previously thought possible?
What about a model based on the record of Earth's history given in Genesis? The Bible describes Earth being called into existence about 6,000 years ago, and Earth originally covered with lush vegetation, then devastated by a worldwide flood about 1,700 years later. This timescale certainly fits with all the scientific discoveries I've made, and just as certainly, water once covered this Earth. In 1927, Noel Odell discovered marine shelly fossils near the very top of Mount Everest. Mountains rising out of the waters is how the Bible describes the end of the worldwide flood. According to that description, the shells near the top of Mount Everest are no surprise at all. And coal and oil, are they the result of the rapid devastation and burial of lush vegetation by a worldwide flood? If so, what about the worldwide flood could have caused such rapid burial? The Bible speaks of the fountains of the great deep breaking out, a strong reference to volcanic eruptions in the pre-flood ocean basins.
This is significant because Ocean Survey researchers recently found an area on the Pacific Ocean floor thickly concentrated with over 1,000 volcanoes. The size of this area is approximately the same as Washington State. Additional ocean floor surveys may well yield many more such discoveries.
The likelihood of extensive volcanic activity during the biblical flood leads us to consider one of the most famous volcanic eruptions in modern time. On May 18, 1980, a giant landslide on the north face of Mount St. Helens in Washington State accompanied an explosion equivalent to 20 million tons of TNT.
This lateral blast of superheated steam, volcanic ash, and dirt leveled over 150 square miles of forest, snapping huge Douglas firs like toothpicks. The landslide debris plunged into Spirit Lake, causing a colossal water wave which washed over the adjacent mountainside over 800 feet above its pre-eruption water level. An average thickness of 300 feet of new sediment dumped into the lake has caused its surface level to be almost 250 feet higher than before the eruption. A massive number of trees felled by the blast were washed into Spirit Lake by the giant water wave. The power of catastrophically driven water to accumulate and bury extensive amounts of vegetation can easily be seen here. The floating log mat on Spirit Lake is only about half its original size because the rest of the logs have sunk to the bottom. If Mount St. Helens had erupted underwater, huge tidal waves hundreds of times larger than the Spirit Lake water wave would have caused the erupted material to be carried over much of the Earth before settling. If thousands of these volcanoes were active, we can begin to imagine the destructive effects a worldwide flood would have had on the topography of the Earth's surface.
This leads us to ask, could such a worldwide flood described in the Bible also be capable of explaining other geological phenomena, such as the Grand Canyon? Some geologists would have you believe that sedimentary deposits were laid down over many millions of years. What they want you to believe is just not true. The fact is, the geology of the Grand Canyon fits a model based on the occurrence of a worldwide flood.
In an attempt to learn where the floodwaters came from, where they went after the flood, and what geological events occurred during the flood. We went to Dr. Walter Brown, the former Chief of Science and Technology Studies at the Air War College and an associate professor at the U.S. Air Force Academy. His development of the hydroplate theory provides the key that unlocks many mysteries about the flood and its effects.
We can see on our planet 17 very strange features that can now be systematically explained as a result of a cataclysmic global flood whose waters erupted from subterranean chambers with an energy release exceeding the explosion of 10 billion hydrogen bombs. This explanation shows us just how rapidly major mountains formed. It explains the coal and oil deposits, rapid continental drift, why ocean floors have huge trenches and hundreds of canyons and volcanoes. It explains the formation of the layered strata and most of the fossil record, the so-called ice ages, and major land canyons, especially the Grand Canyon. The pre-flood Earth probably had one very large supercontinent containing lush vegetation, seas, rivers, and minor mountains. According to the hydroplate theory, the pre-flood Earth had a lot of subterranean water, about half of what is now in our oceans. This water was in interconnected chambers forming a thin spherical shell about half a mile thick, perhaps 10 miles below the Earth's surface. Increasing pressure in the subterranean water chamber stretched the overlying crust just as a balloon stretches when the pressure inside increases. Failure in the crust began with a microscopic crack which grew in both directions at about 3 miles per second. The crack, following the path of least resistance, encircled the globe in about 2 hours. As the crack raced around the Earth, the overlying crust opened up like a rip in a tightly stretched cloth. The subterranean water was under extreme pressure because of the weight of the 10 miles of rock pressing down on it. So the water exploded violently out of the rupture. Calculations show that all along this globe-encircling crack, fountains of water jetted supersonically over 20 miles into the atmosphere. The spray from this enormous fountain produced torrential rains such as the Earth has never experienced before or after. The Bible states that all the fountains of the great deep burst open on one day. And it describes these events about 4,500 years ago, which we can now tie together scientifically in cause and effect order as the hydroplate theory. The fountains of the great deep and the expanding steam produced violent winds, some of the water jetting high above the cold stratosphere, froze into supercooled ice crystals and produced some massive ice dumps, burying, suffocating, and instantly freezing many animals. The high-pressure fountains eroded the rock on both sides of the crack and even threw up the limy contents of many pre-flood seas. Huge volumes of sediments settled out of this muddy water all over the Earth. These sediments trapped and buried plants and animals, forming the fossil record. The flooding uprooted vegetation, moving it to regions where it accumulated and quickly became coal and oil by processes we can duplicate in the laboratory today. Experiments show that as erosion widened the rupture, its width became so great that the compressed rock beneath the subterranean chamber sprung upward, giving birth to the mid-oceanic ridge that wraps around the Earth like the seam of a baseball.